All right, in this video, what I want to do is talk about how to construct box plots. This is something that I did not focus on in class. I think I've explicitly said that I will not ask you to create a box plot on the exam, but there is one question on the quiz, so I wanted to cover it. And the idea with the box plot is that it's kind of a big picture overview of all your data. So here we have a data. This is an example from the book. I forgot to write down. It's example 324. So from page 131 from the book. So this is just data that I took, and then we'll construct the box plot together. So what we're going to do is we're going to calculate the median and then the other quartile. So Q1, Q2, Q3. And there's a few different ways to do this, but I want to get proficient at R. So we're just going to put in this data set in R. This is a data set with 20 values in it, so it's a sample of size 20. And there's a few different ways to get the quantiles. I think the easiest way is just to use the 5-number summary, so 5num x. So if x is our data set, then you would type 5, write this a little more legibly, 5num, there's no space, x. And that's a code that's on our R worksheet. So that's a way that you can get the minimum, Q1, Q2, Q3, and the maximum. And then with Q1, Q2, and Q3, we're going to put those, the way I have the data is horizontally. So we're going to put these as vertical tick marks in those different spots. So we had 23, which is about here. Our median was 30.5, and I'm going to make that slightly thicker. And then Q3 was 36.5, which is just roughly here. And then we're going to make a little box out of this. Okay, and that's the main part of this. And then the next thing that we need to do is to determine whether there are any potential outliers. And the way to do that is to use what's called the interquartile range. The IQR is defined as Q3 minus Q1, which in our case is going to be 36.5. So we got 36.5 minus 23. So that would be 13.5. And then we use the interquartile range. This tells you, by the way, the length of the interval containing half the data. Because if you go from Q1 to Q3, that's the quantile for 25% to 75%. So half the data lies in that interval. The middle half of the data lies in that interval. And so that's the interquartile range. And then we use this to calculate the lower limit and the upper limit. And again, this is not anything that I've emphasized before. I may have said this previously, so I apologize if I'm repeating myself, but I just want to add it to the video so it's self-contained. So the lower limit is going to be defined as the first quartile minus 1.5 times the IQR, the interquartile range. So in our case, that's going to be Q1 was 23 minus 1.5 times our interquartile range, which was 13.5. And when we do this, it turns out that we're going to end up with 2.75 is our lower limit. Our upper limit is calculated similarly as Q3 plus 1.5 times the IQR. So that's going to be 36.5 plus 1.5 times 13.5. And that works out to 56.75. I did these ahead of time. So 56.75. And then the reason why you care about the lower limit and the upper limit is that any value that's outside that's lower than the lower limit or above the upper limit is called a potential outlier. So if you have any value that's beyond those two numbers, that's going to be a potential outlier. And if we go back up to our data, we indeed have one potential outlier, and that would be 66. That's a number that's greater than 56.75, so that's a potential outlier. What we do with potential outliers is you put them as stars or asterisks on the chart. So 66 is roughly, say about here, so we'll put that as a star. And then what we're going to do is we're going to put the adjacent values down. So the next value next to 66, the next previous value is 43. And so we'll put 43 here, and that's kind of our, we're going to put a small vertical line there. And likewise, our smallest value is 5. We don't have anything beyond 5 anyways. And then we can connect these. I'm going to move that up just a little bit so it looks a little nicer. And then we can connect this one as well. Okay, and there's our box plot. That's really all there is to it. Again, standard precaution, do not use R for box plots. They have a different way of calculating potential outliers. They have a different way of calculating the lower and upper limits. And so box plot is not to be used to construct, R is not to be used to construct box plots for this course anyway. So again, whenever you do these problems where you have to find the quantiles or quartiles or whatever you want to call them, there's different choices that you have to make, whether you're going to include the median in each data set and so on. And there's all sorts of different decisions. And in fact, R has 9 different ways that you can kind of divvy up the data. So the box plot function that's built into R should not be used for our course. Okay.